Okie dokes, we're going to be on page 12 of the statistics packet. Should be page 12. If it's not, what you're going to look for is the page with the number line on it, or line plot on it that has number of pets on the top. Number of pets. So what we're going to do today is the last couple days we've created line plots. And today we're not going to create a line plot, but we're going to use line plots that have already been created. And what's called analyze them. What that means is we're going to look for information in the line plots, like the mean, the median, the mode, the range, specific data points to help us answer questions. Okay, so let's start with number of pets. Let's look at this graph here. We have 0 through 4 on the bottom, and we have data points for each number here. It says, what statistical question could have been asked to gather this information? Now remember, a statistical question is one where you would ask a lot of people and get a variety of answers. So the question might be, what is the typical number of pets a person in our class has? So that's an example of a statistical question. You'd have to gather a lot of data to answer it. It's also numerical because the answers you get would be numbers. All right, let's try the next one here. It says, how many people responded to this question? So each X is a data point. Okay, so 3 people had 0, 2 people had 1. So to find out how many people responded, we'd count the X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 people responded to the question. That's how many data points there were. What is the greatest number of pets one person had? Some people had 0. One person had 4. That was the greatest number of pets that an individual person had. Now, some people might look at this and say 2, but 2 is the most common response. It wasn't necessarily what is the greatest number of pets someone had. So that's going to be 4. All right. Number 4 says, are there outliers? And an outlier, you could think of it as like an extreme value. Now, there are no outliers in this line plot. If you look at it, all the numbers are pretty close together. 0, 1, 2, 3, 4. If there was somebody with like 80 pets, that would be extreme. That would be an outlier. Even someone with like 10 pets, that would still be pretty extreme. So are there outliers? There are no outliers in this one. We'll see a couple today that do have outliers, but this one does not have one. All right, let's check out the measures of the center. We have the mean. So for the mean, we're going to add up all of the data points and then divide it by how many there were. So let's see, there's 0. For 0, we had 2 responses. Plus 1, there were 2 responses. Plus 2, there were 1, 2, 3. So we're going to do 2 times 3. Plus 3 times 2, because there were 2 3s, and then 1, 4. So it'd be 4 times 1. We're going to divide that whole thing by how many there were. There were 10 data points. All right, let's add those up. 0 times 2 is 0, plus 1 times 2 is 2. 2 times 3 is 6. 3 times 2 is 6. Another 6. 4 times 1 is 4. And we're going to divide that all by 10. Well, 0 plus 2 is 2, plus 6 is 8, plus 6 is 14, plus 4 is 18, divided by 10. Equals 10. 18 divided by 10 would be 1.8 pets. So that seems reasonable because that's about the middle of the data, this number is saying. If you look at the line plot, 1.8 would be about right here. So that's kind of in the middle of the data. If we got like 5, that wouldn't make any sense because no one even had 5 pets or anywhere close, I guess, except for 4. So that's about the middle. Let's check out the median. So with the median, what we're going to do is we're going to take each data point, we have 2 zeros, and we're going to line them up from least to greatest. 2 1s, 3 2s, 2 3s, and a 4. And we're going to use this crossing out method to find either the middle 2 or the middle 1. Now, there were 10 data points, so it's an even number. So we're actually going to have 2 in the middle. So we'll stop when there's 2 in the middle. So we're going to go least to greatest. We're going to keep going least to greatest until we see that there's 2 in the middle because we have an even number of data points. And there's our 2 in the middle. Well, since there's 2 in the middle, we have to find the number that's exactly between these two numbers. What number is between 2 and 2? It's 2. So the answer would be the median is 2 pets, which is, again, that's, pretty close to the middle. That's about the middle of the data. So the number 6 asks, which measure of center best describes the data? Why that one? So in number 4, we said there were no outliers. And outliers, they affect the mean. Because if we had somebody had 80 pets, what that would do is that would pull the mean up. Okay? That would pull it up. So let's say somebody did have 80 pets. So I'm going to add that data point. So again, the total would be 98 divided by 11. If somebody had 80 pets, that would pull the mean up to 8, which wouldn't really be a good measure of the center. So because there is no outlier, that means the mean is a good one to use because you don't have an extreme value pulling the mean up. So we're going to say we use the mean because there are no outliers. The median is good when there are outliers. So when we have an outlier, that's when we'd prefer the median because then the outlier doesn't have as much of an effect on that measure of center because there are no outliers. Okay. All right, let's go on to the next one. Let's try the next one here. All right, this is a line plot below shows the number of people that visited the Buffalo Museum of Science on certain days. All right, so we have a variety of visitors. Each X stands for a day. So 4 days, 56 people came. 1 day, 58 people came, so on and so forth. What was the mode? Now the mode is the most popular data set. Which is the number that came up the most? That would be 56. That's the mode. How many different data points were collected? We did this in the previous question. We're going to count the number of data points. So if 56 had 1, 2, 3, 4, there's one here. That's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What does each data point stand for? So it looks like each day they determined how many visitors they had. So each X stands for a day. The museum was open. So each data point stands for a day the museum was open. So again, if there was a data point on here for 1,200 people, that'd be an outlier. That's really, really far away from the data. But it doesn't look like there are any outliers. These numbers are pretty close together. What is the range of the data? And remember, the range is the greatest data point, which is 68, minus the least, which in this case would be 56. So you might be thinking, well, what about 55? Well, there's no data points there. So we're looking at the greatest data point and the least data point, and we're going to subtract them. And we get 12. So what does the range show? Well, in this case, the range shows that The data is spread out by 12 visitors. So the difference between the greatest number of visitors and the least number of visitors is 12. The keyword there is spread. That shows how much the data is spread out. The less this number is, the more the data is close together. So if the range was like 100, that shows the numbers are a little bit farther apart for an example like this. All right, let's talk about shape in the next one, the shape of the data. All right, it says describe the shape of the data. We're going to look at clusters first. And a cluster is where there's like a lot of data in a small area. And when I'm looking at this graph of the number of magazines sold in Mrs. Houseman's homeroom, I'm looking at a set of data, and I can see that there's a lot of data here in this small space. So I'm going to think of that as like a cluster. Okay, so there's a cluster between or from 23 to 25. The cluster is from 23 to 25. I was almost thinking like 2020 itself would be a cluster because there's a lot of data there. So, you know, if you said that 20 was a cluster, that would also kind of make sense. There's a lot of data on that one number. All right, so there's two gaps here. You can see the two gaps. One's here and one's here. So one, we can say just like a one gap is between 18 and 20. And another is between 20 and 23. Let's look for peaks. There's one peak, and that's where there's the most data. That's the top of, not the top, but it's the where the most data is on one data point. The peak is at 20, right at 20. All right, so that's the shape of the data. We can talk about clusters, we can talk about gaps and peaks. All right, let's try the next one here. Okay, let's look at this temperature. This plot shows the temperatures in Orchard Park during 1 week. During which month could this data have been collected? How can you tell? I would say maybe like January or February or December. And how can we tell? Well, if you look at the temperatures, those are pretty cold. 20s, you know, it's below 32, it's below freezing. So how can you tell? We can tell it's one of those months because it's cold. All right, let's check out the mean. The mean is when we add these all up and divide by how many data points. So we have 121. I'm just going to write 21 as by itself because there's only one of them. 2 22s, that's when we multiply. We have 2 22s, or 22 times 2. Plus 3 23s, 23 times 3. Plus a single solitary, 29. 29. And we're going to divide that by how many data points we have, which was 1, 2, 3, 4, 5, 6, 7. Divided by 7. So you have 21 plus 22 times 2 is 44 plus 23 times 3 is 69 plus 29 divided by 7. So I'm just going to take a moment to add these up. We got 21 plus 44 plus 69 plus 29. So it's 163 divided by 7. Now, I know 7 goes into 140 20 times. It's going to be 20. 7 goes into 23 3 times, and there's going to be 2 7s left over. So it's 23 and 2 7s. This would be degrees. That would be the mean. Let's check out the median. That looks pretty, 23.2 in 2/7, about right here. Okay, let's check out the median. It's about the middle. So we got 21. We're going to line up the data points. We have two 22s, so we're going to count two 22s, three 23s, and a 29. And then we're going to use the cross-out method. We're going to cross these off from least to greatest. Now we have 7 data points, which is an odd number. So we're going to have one data point in the middle. And that data point is 23. 23. All right. So the median is 23 degrees. Now the question is, they're pretty close, the mean and the median. These two numbers are really close. They're off by only 2/7. So which one would be more appropriate? Which one would be better to use? And in this case, we have 20. See 29 here? It's like an outlier. It's not necessarily extreme, but it's really far away from the other data points. All the other data points are grouped at the other end of the number line. And then we have 29 that's sort of out by itself. So we're going to use the median because there is an outlier. So we use the median because there is an outlier. All right. If there was no outlier, we'd use the mean. Like if 29 was gone, we would probably use the mean there. All right, we got one more here we're going to take a look at, and that's the sweaters shop I own. It's called Mr. Lovering's Adequate Sweaters, and this is a line plot showing the prices of sweaters at the new store. So each price represents a different sweater, I guess. So 25 is one sweater. There's one sweater for 30, one for 40. So these are the sales. This is how many sweaters I've sold. So how many different sweaters am I selling? I'm selling 5 sweaters. One for $25, one for 30, one for 40, one for 45, and one for 65. So let's find the mean then. The mean cost of these sweaters. Actually, you know what? I'm selling 11 sweaters. I'm sorry. I'm selling 11 sweaters. So we have 4 I'm selling for $25. 2 would be 30. So 4 plus 2, 6, 7, 8, 9, 10. Actually, it's 10. My bad. My bad. I miscounted. I saw one more than I actually had. So you got 10 sweaters here I'm selling. I'm going to find the measures of center. Here we go. 25 times 4. Because I got 4 of them. We're going to find the mean here. 30 times 2 plus 40 times 2 plus 45 plus 65. I think I wrote these way too big. And then divide it all because there's 10 sweaters divided by 10. So I know that's 100 plus 60, which is 160 plus 80, which is 240. These two together are 110. So 110 plus 240 is 350 divided by 10. Whoop. Which is $35. That's the average cost of a sweater at my store. That's not bad for a sweater. All right, let's try the median here. Here we go. We're going to line these numbers up. We have 25. We have 4 25s. We have 2 30s, 30 and 30. We have a 40 and a 40. We have a 45 and a 65. So we have 10 data points. So we're going to have 2 in the middle instead of just 1. So we're going to go back and forth, back and forth, back and forth. So we have 2 in the middle, and there they are, 2 in the middle. Okay, so what's in the middle of 30 and 30? Well, it would be 30. So we're thinking here, which number would we use? Which number would we use? The mean or the median? And to think about that, we'd have to consider whether we have an outlier or not. The 65, it's close. This one would be close to an outlier. Let's say that it is. Let's just say that this 65, because it looks pretty far away from the other set. That's an expensive sweater if you're going to go to my store to buy one. So that's an outlier. If we have an outlier, we're going to use the median to find the center. So which measure of center best describes the data? So we use the median because there's an outlier. All right. If someone brought one of each sweater, how much would they spend? Well, we already have that answer because we already added up all the costs of all the sweaters that I'm selling. And that number is right here. When we added up all those numbers, if somebody bought one of each sweater, they would have to spend $350. Not bad for 10 sweaters. That'll last you, maybe a decade of sweaters. All right, let's describe the shape. So we have clusters. We have a cluster. Yeah, I'd say we have a cluster here. The cluster is from 25 to 30. Let's see. There's two gaps. There's one gap here, and then there's a big gap right here. So say one gap is between 30 and 40. So we'll say the other gap is between 45 and 65. All right, last question. What's the peak? There is a peak at 25. That's the highest data point, or the one with the most data points, I should say. There is a peak at 25. All right. So that's it for line plot analysis. If you have any questions, please let me know. Hope you're doing well, and I hope to see you soon. Have a great day. Bye-bye.